What's going on, guys? Let's look at this problem right here. Here the question is asking, in the circuit of figure, beta is equal to 100 and VA is equal to infinity. A part is asking if the collector current of Q1 is equal to 0.5 milliampere, calculate the value of IS. Now let's see how to do that. First, we are going to draw the Thevenin equivalent circuit of this one. That's going to look like this. Okay, Thevenin equivalent, Thevenin's equivalent, and here we will have a resistor, and also here we will have another resistor. This is 50 kilo ohm and this one is 30 kilo ohm, and here we will have 2.5 voltage, and that's it. Now let's go ahead and calculate VThevenin. VThevenin is basically 2.5 voltage. Here we have 2.5 voltage multiplied by this voltage division. Like if you want to calculate the voltage across the 30 kilo ohm, we have to put that one on the top, and addition of both to 50 kilo ohm plus 30 kilo ohm. And here we can, if you calculate this one, you will get 2.5 voltage multiplied by 0.375, and that gives us 0.9375 voltage, and that is equivalent to 937.5 millivoltage. And RThevenin is multiplication over division. So 30 kilo ohm multiplied by 50 kilo ohm divides by 30 kilo ohm plus 50 kilo ohm. That is equivalent to 1500 mega ohm over 80 kilo ohm. That's equivalent to 18.75 kilo ohm. This is RThevenin. Now VThevenin and RThevenin are calculated. The next thing is we are going to calculate IB current. IB current is equal to IC over beta. IC is 0.5 milliampere, that's provided right here. 0.5 milliampere divided by beta, that is 100. That is equivalent to 5 microampere. And IB is equivalent to VThevenin minus VBE divided by RThevenin. VBE is basically VThevenin minus IB RThevenin, that is 937.5 millivoltage minus 5 microampere multiplied by 18.75 kilo ohm, and this gives us 937.5 millivoltage minus 93.75 millivoltage, and that's equivalent to 843.75 millivoltage. Okay, VB this one. Here the question is asking us to find out the IS. Now we have VB. VB is equivalent to VT ln of IC over IS. We are trying to find IS. IC is already there, that is 0.5, and Vt is a constant value, that's 26 millivoltage always, and Vb we just found it out, so we can solve for Is. So Is, let's plug all the values. This is 843.75 is equivalent to 26 millivoltage ln of 0.5 milliampere divided by Is. Therefore Is is equivalent to 4.03 times 10 to the power of minus 18 ampere, and this is the Is current. Now this is the A part. A part is this. Now let's go ahead and do the B part. Now we are going to do the B part. If Q1 is biased at the edge of saturation, calculate the value of Is. Now to calculate the value of Is, first we have to know Vb is equal to Vce. Now Vce can be calculated using this formula. Vcc, that's 2.5 voltage minus Ic times Rc. Ic times Rc is 3 kilo ohm. 3 kilo ohm right here. Now Ic is basically, Ic can be written as beta times Ib, and beta times, instead of Ib is base current, instead of Ib we can put V Thevenin minus Vbe divided by R Thevenin. Okay, now we have this formula for Ic. Now let's go ahead and plug it in this main equation. Vce is equivalent to 2.5 minus, instead of Ic I plug this one, beta V Thevenin minus Vbe divided by R Thevenin, and beta V Thevenin minus Vbe over R Thevenin multiply by 3 kilo ohm. This is altogether for Ic, multiply by 3 kilo ohm. We are applying this equation. Okay, multiplying by 3 kilo ohm. Now let's go ahead and plug the values. 2.5 voltage minus beta is 100, that's provided in the question, and V Thevenin V Thevenin is 937. We have that one here, 937.5 millivoltage. We calculated in the previous one. I showed you before I erase it. I showed you how to calculate. So V Thevenin we already calculated that one. That is 937.5 millivoltage minus VBE over R Thevenin, that is 18.75 kilo ohm. Okay, now the next thing is 18.75 kilo ohm, and also we have, and if you calculate this VBE you will get 830 millivoltage, and this is for VBE. But here the question is asking us to find out the Is. Let's go ahead and calculate that one. Is is equivalent to Ic over exponential VBE over Vt. Now Ic is, instead of Ic we can replace it with beta times Ib, that is, we saw that right here, instead of Ib we can put this formula, That one is V Thevenin minus VBE divided by R Thevenin divided by exponential VBE VT divided by VT. Let's go and plug all the values. 100 and V Thevenin is 937.5 millivoltage minus 830 millivoltage divided by R Thevenin, that is 18.75 kilo ohm divided by exponential VBE is 830 millivoltage and VT is 26 millivoltage, and this is equivalent to 7.84 times 10 to the power of minus 18 ampere, and this is the IS current. I hope you guys find this video helpful. Thanks for watching, and if you are trying to learn electronics, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.